Hi, my name is Cameron Akbarzadeh and this is Lab 4, Spring Mass System. The purpose of this lab is to examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the string. This process was done by using Tracker and VPython with the fundamental physics principles of Newton's second law and the energy principle. The result of this was that the spring mass system correlated with the energy principle, since the predicted and observed models are incredibly similar. To start off, we took a video of the spring mass system and saw that it would go side to side, as you can see in the video in front of you. We set a calibration SIC of 0.7 meters and set axes at the top of the spring mass system at a fixed point. The data from Tracker allowed us to find additional data from VPython. There, we set the code. We started off by setting the ball's mass to be 0.402 kilograms, then the initial position of the system to be negative 0.11, negative 0.6280, and the initial velocity was a zero vector. Afterwards, we set the gravitational constant as 9.8 and the spring constant as 6.83 newtons over meters from the formula of 4 pi squared meters over t squared. From that k, we found L naught, their static equilibrium, where the force of the spring equals the gravitational force. There, L naught equals the L vector minus mg over k, which gives us a value of 0.123 meters. There, we use the energy principle of delta E equals the kinetic energy plus the potential energy in the spring plus the potential energy in gravity. Afterwards, we used Newton's second law to find the F net using the formula of F net equals F gravity plus the force of the spring. Then we found the ball's new velocities and positions also using Newton's second law. Afterwards, we updated the spring and calculated the energy changes. After that, we put the code into VPython. As you can see, the code with the blue arrow representing the spring force and the black arrow, or gravitational force, is pulling it down. The blue ball represents the predicted motion, and the red ball represents the actual motion. In the graph from Python, we see that the spring and gravitational potential energy are opposites of each other with a kinetic energy coming in between them. There you can see the yellow line, which represents F net. So what does all this mean? Well, the energy principle in this case is satisfied as shown in the graph, since F net is all on the x-axis, meaning that it's 0. After that, I used Tracker and made 2 estimates of oscillation periods from the x and y position data. The time interval for x and y should be different in this case because it oscillated in different directions at different times. Thus, I got a t of 1.53 seconds from the x position and 1.43 seconds from the y position. Thank you so much for watching this video.